If you're losing marks in physics, it is not because you don't know theory, it is because you're panicking in numericals. In the next 30 minutes, I'll be solving 20 most repeated board level numericals from the last 10 years. And listen carefully, at least 5 of these patterns will appear in your exam for sure. If you can solve these confidently, you're definitely securing 15 to 20 marks minimum. Each of this question is different and it is of a specific type that is repeated every year. So watch for each question. Let's get started. First question from light, reflection and refraction. In this whole question, they have not told what mirror it is. So this is a standard CBSE model where they don't tell you which mirror or lens it is and you have to figure out from the information given. So if you see, it is given that it's a real and inverted image. Real and inverted images are only formed in concave mirror. So that's the first conclusion we draw. Now we know that it's a concave mirror. The second information we have is that magnification is -1. Magnification is -1 means that it is real and inverted, that's why it is minus. The 1 means that it is the same size of that of an object. So when is it that in a concave mirror the object and image are of same size? When the object is at C, right? So with this we conclude that the object is at C. So if the object is at C, the image will be where? The image will also be at C. The image is at C. So since the object is at C as well, the object distance will also be -30 centimeters. Right, we're taking -30 as per the sign convention. So we've answered the first part where we're saying that the object is exactly where the image is because the magnification is -1. This is a standard CBSE template to get questions on magnification of -1, which clearly states where you have to remember the table of where the object and image lie so that you can answer these questions. Now, second part of this question states that where would the image be if the object distance is moved to 15 centimeters? I need focal length, right, to find the image distance. So how can I get focal length? Previously, my object was at 30, which is the at C distance. So the distance at C is nothing but R. So R is equal to 30 centimeters, right? So the focal length will be R by 2, which is equal to -30 by 2, which is equal to -15 centimeters, right? So if f is equal to -15 and the object is also placed at 15, that means that the object is at focus. So if the object is at focus, the image will be at infinity, right? So the image will be at infinity. This is how you solve very basic 2 mark 3 mark questions from light reflection chapter, where it is mostly from the verbal of the question. So these kind of questions should be practiced so that you can answer them better. Moving on to the next question. So what are all the information we have? We know that it's a convex mirror. We know that it's the focal length equals to 20 centimeters. I'm taking positive focal length because again always draw a number line. Put a mirror. Now this is a convex mirror. So the focal length will be on this side, or anything this side is positive. So focal length is 20. And she placed the object at a distance of 20 centimeters in front of the concave mirror. So this is negative as always. Object distance is negative. So where is the image likely to be? We need to find what is the image distance. So let us use the mirror formula to solve this question. So the mirror formula is 1 by V plus 1 by U is equal to 1 by F. So 1 by V will be equal to 1 by F minus 1 by U. So if I substitute here 1 by plus 20 minus of minus 20, this would be equal to 20. 1 plus 1, the minus become plus, which is equal to 2 by 20. So the image distance will be 10 centimeters and it is positive. Yes, because the image is usually formed behind the mirror in case of a convex mirror. So the answer is right and we have validated it with theory, that is it is coming positive because image will be formed this side and it will be virtual erect. So it is true. Now we are going to introduce height of the image and object. These are the questions that usually come for 3 marks. Whenever there is a question with height of the object and focal length and object distance is given, usually the image distance and height is asked. We are going to solve this question We are going to use a trick in which you will never go wrong with sign convention, and we are going to verify the answer with theory so that you can be sure shot. Sometimes these questions come with the ray diagram in the end, like you have to solve the numerical and then draw the ray diagram to show this situation. That is when it would come for 5 marks. The ray diagram would be for 2 marks and the numerical would be 3, or vice versa. So let's get started with the information that is given. So if we have to solve this question, start writing with what we know. We know that the height of the object is 3 centimeters, positive because it is kept upright. Now, concave mirror is given. So it's already given that it's a concave mirror. And you have the focal length. If you try to remember what mirror, what focal length, you will always go wrong, because there is concave mirror, concave lens also, and it gets confusing. So always do this. Draw a number line, put the mirror. Now this mirror will always converge things into its point to get the focal length, right? Which is the concave mirror, and anything this side is negative. So the focal length will be negative 12 centimeters. Now distance of the object from the mirror is 18. So object is always placed this side of the mirror. So you take it to be minus 18 centimeters. We need to find the image distance and height of the image. So let's get started with using the mirror formula, which is 1 by V plus 1 by U is equal to 1 by F. So 1 by V will be equal to 1 by F minus of 1 by U. So if I substitute 1 by minus 12 minus of minus 18 minus of 1 by minus 18. So the LCM of 12 and 18 is 36. So this is minus 3, this plus becomes here, and this is 18 twos are. This is equal to minus 1 by 36. So V is equal to minus 36 centimeters. Now to find the magnification, etc. Now after the whole thing finishes, I'll show you how to verify that your answer is absolutely right. No need to worry about it. So let's say the height of the object is, so the magnification is given by minus V by U for the mirror. So if I write minus, V is minus 36 divided by U. U is minus 18. So minus cancelled. So you get minus 2 times, which is the magnification. So the height of the image will be magnification into height of the object, right? So it is minus 2 into 3, which is equal to minus 6 centimeters. Now let's see how I verify my answer. So the focal length is 12, okay, somewhere at 12 centimeters. The object is placed at 18. So 12 2s is how much? 12 2s is 24. So the object is not beyond C, it is between C and F, because this, if let's say this is 24, it is between C and F. So if the object is between C and F, the image will be beyond C. So image should be greater than 24, which is right. Second thing, now the image will be enlarged and real and inverted in the case of, in this case where it is between C and F. So if it is real and inverted, the magnification is negative, which shows that it is real and inverted, and you didn't get a decimal, you got a whole number, that shows that it is enlarged, right? If it is, so basically magnification 2 means it is twice the object size, which is what it is. So it is right. So this is how you validate your answer with theory, so that you're sure that this is not wrong. And if they ask you for a 5 marker and ask you to draw the ray diagram for this, you draw the ray diagram for the scenario of the object placed between C and F. Okay, so let's move ahead with refractive index question. So let us start here. Absolute refractive indices of two media P and Q are 1.3. So first, see, this is one of the most ignored parts of this chapter, because we are so focused on mirrors and lenses. The refractive index Snell's law is ignored, and sometimes CBSE throws a googly by asking a question here. So better get prepared, because it's hardly anything. It's very straightforward. There's one formula to remember. So better be prepared on this front so that you don't lose these marks. So first we have the refractive index of P, absolute refractive index, which is 1.33, and absolute refractive index of Q, which is 2.52. So what is absolute refractive index? It is speed of light in vacuum divided by the speed of light in medium. So we have the speed of light in medium P, which is 2 into 10 to the power 8 meters per second. So what is the first part? They are asking what is the speed of light in medium Q. We know that C is equal to 3 into 10 to the power 8 meters per second, right? It's a given thing, that is the vacuum. So definitely refractive index of Q is equal to C by VQ. So VQ will be equal to C by nu Q. So if I substitute here 3 into 10 to the power 8 divided by the refractive index of Q, which is 2.52, this is somewhere close to 1.19 into 10 to the power 8 meters per second. So that is what it is. Now the second part of question, the angle of incidence I is given to be 0 degrees. Right? They're asking what is the angle of refraction or what will be the path of it. So here we are going to apply the Snell's law. What is Snell's law? Snell's law states that sine I by sine R is equal to a constant, and this constant is usually refractive index of P with respect to Q. So basically it is traveling from P to Q, so you take NP by NQ. So if I substitute that, this is there in your textbook. If you have read the fine font, you can see this in your textbook. It's not something new. Where they describe that the constant is the ratio of the refractive indexes of the two mediums. So if I take NQ sine I is equal to NP sine R, then I can write that NQ, which is 2.52 into sine I, which is 0 degrees, is equal to 1.33 into sine R. But this sine 0 becomes 0. So that means that R is also equal to 0 degrees. So the path of light traveling in medium Q will be straight, like it will go straight. If this is the light, it will travel straight along the normal without any deviation. So this is how you solve questions on refractive index. Remember that it's just two formulas, this formula and the refractive index with respect to one medium formula, and the Snell's law formula which you need to prepare. Once you know this is easy. And this part B is what differentiates toppers. Remembering this, trying to solve it using Snell's law is what differentiates you from everyone from toppers. So remember these things. Moving on to the next question on lenses. So again, here's the question where they are not telling which lens it is and we need to determine. Now, as you see, they have not given what lens it is. They have just said it's a converging lens. So from that, we have to determine. So let's start writing it. So converging lens is basically something that converges. So it is basically your convex lens, right? Only your convex lens converges all rays. So it's a converging lens. So the rest of the information that is given is object height is 10 centimeters. It is placed 25 centimeters away. So image distance is always positive because it's placed this side is negative, this side is positive, right? Now the focal length, since it converges this side, the focal length will be positive for this mirror, right? Always draw one diagram on the side. It hardly takes time and you will not go wrong. Why do you want to struggle remembering convex is positive, concave is negative? You might go wrong easily. So always draw one diagram. Less than 5 minutes it will take, and it will be easy for you in the exam, and you can be sure that you're never wrong. So you need to find the image here, image distance, and the height of the image. So let's get started with the lens formula, which is 1 by V minus 1 by U is equal to 1 by F. So the one thing that I always remember, there is a minus in the lens formula. So there is no minus in the mirror formula. Since I am putting a minus in the lens formula, the magnification has no minus. So the mirror has a minus in its magnification formula. This is something I have remembered since my 10th class, which is literally 12 years back. So you can always use this, you will not go wrong with it. So now if I convert this to 1 by V, which is equal to 1 by F plus 1 by U, I will substitute that 1 by 15 plus 1 by minus 25. So the LCM of 15 and 25 will be 75. So this is 5 minus 3, that is 2 by 75. So your V will be equal to 75 by 2, which is equal to 37.5 centimeters. Now again, to find the image distance, we use the magnification, which is equal to, since I've already put a minus here, there is no minus in the magnification. So V by U is, so V is 37.5 by U, which is minus 25, which is which is equal to 1.5 minus, right? You're getting minus 1.5. So image height will be magnification into object height, which is equal to minus 1.5 into 10, which is equal to 15, minus 15 centimeters. Now you see, again we will check our answer and it will be right. So the focal length or the f2 point is 15. So 2f2 point will be 30. So the object is placed at, so again f1 point also will be 15 and 2f2 point will be 30. Now the object is placed 25, so which is between 2f1 and f1 point it is placed. So the image will be beyond 2f2 point, right? So it is beyond 2f2. Yes, I've got an answer which is greater than 30 centimeters. Now next, it will be enlarged, real and inverted. It is 1.5, it is enlarged. It is real and inverted because there is a negative side, and also because your image is from this side of the mirror, you got a positive image distance. So your answer is 100% accurate. You can be very sure of this. See, the moment you find out that something is wrong here, it is not falling in line with theory, immediately check your sign convention. You can obviously get back to the right answer. That is how you can ensure that you are getting the right answer at every stage. Again, if it comes for 5 marks, you will have to draw a ray diagram for this. That is how they would test you. Now coming to the next and the last question of light reflection. So we did a question on concave mirror, convex mirror, refractive indexes, and we did 2 questions on mirrors actually, and then we did 1 question on convex lens, and 1 more we'll be doing now, which also has some power involved. So the focal length of a lens is given as minus 10 centimeters. So this is how the next way they'll ask. They'll only give you sign convention from which you should draw what is the length of it. So because it is minus 10, that means the focal length, whatever mirror is placed here, the focal length is coming this side. So basically for a lens, if the focal length is this side, it will, refracted rays will always be on the opposite side. So it is going like that, but the focal length is on this side, means it is a concave lens. It is a concave lens. So that is what you understand. Now the nature of the lens is concave lens, which you have already determined. Now we have to find the power. So to find the power, again the simple thing that we all miss is converting centimeters to meters, because the power of the lens, the unit diopter, is 1 by meter. So you have to convert this into meters. So 10 centimeters is nothing but 0.1 meters. So the power will be 1 by 0.1, which is equal to 10 diopter. Okay, so always remember that there's a conversion involved when it comes to power calculation. This is how you can prepare well for your light reflection chapter. We have done a question in all the possible formats that they could be asked. 5 of these are guaranteed repeated models, so you will get a question in these formats for sure. Hope you have got 6 out of 6 so far. So let's get started and move to the next chapter, which is human eye and the colorful world. As you know, this chapter is more theory based, but there are some numericals that can be asked. So we will do one on defects, like 2-3 questions on defects, and 1 questions on prism, and 1 is on natural phenomenon, so that you get a taste of how numericals can come from this chapter. You have 2 lenses here. Let's say lens 1 has a power of minus 4 diopter, and the second lens has the power of plus 2 diopter. Okay, so if I take the focal length of this, it will be 1 by minus 4, which is equal to 0.25 meters or 25 centimeters, and it is negative. So if it is negative, it is a concave lens. And focal length 2, which is 1 by 2, which is equal to 0.5, which is nothing but 50 centimeters, and it is positive. Since it's positive, it's a convex lens. Now distance vision is corrected by a concave lens because it diverges so that it hits back on the retina. So distant vision will get corrected by a concave lens. So this is how some numericals can come from this. Now this second question is the format that is mostly asked for defects of vision. So you need to practice this accordingly. Study the diagram given below and answer the following questions. Name the defect of vision represented in the diagram. Give reason for your answer. Okay, so what is the defect that is represented here? So the defect that is represented here is, it is a it is the situation of it is falling outside the retina. So that means this is hypermetropia, right? If it forms in front of the mirror, it's myopia. Now what is the reason for it? So the shortening of eyeball is one of the reason for this defect. And what will be the diagram to show the correction of it? So you can draw the eyeball, the lens, right? Now this is corrected using a convex lens which converges all the rays back into the retina. This is how you draw it. Always remember to label, arrows, all of these things will carry marks. See, even if your diagram is not that neat like mine is right now, it's really bad, right? You can still draw the right lens, the arrows, the labeling, and get better marks, right? So this is the default question of this one. Either you can get hypermetropia or myopia here. Always remember which lens corrects which lens, which defect, and you can answer these questions better. Now let us answer one of the questions on prism. Okay, so the following diagram shows dispersion of white light by a glass prism. The colors of P and Q are. So as you see, white light is thrown and P has bent the most and Q has bent the least. So which color bends the most? So violet color bends the most and red color bends the least. So P is violet and Q will be red. You need to remember this because always remember it is like V. This is the easiest way to remember. It goes V to R. Okay, so the one which is lowest is V, the topmost is R. So that is how you can always mark this answer. These are usually asked as MCQs, not as this one. And when it's MCQ, you get further confused because you'll see 4 or 5 options. It says violet, red violet, blue violet, red green, all those colors. You get confused automatically. So that is why always in such confusing situations, don't read options. Just see the question and answer accordingly and then pick the answer after that. Now this is one of the question on ray diagrams that was asked on natural phenomenon that was asked last year, where the diagram as such was not in your textbook, but they were asked to draw it and mark where dispersion occurs, internal reflection occurs, and where refraction occurs in rainbow formation, and listing 2 conditions for observing rainbow. Is one of a key and very good question that came. So let me start by drawing my raindrop and the sun on this side. So if this is my white light that hits, my blue light will go down and bend the most and again bend out maximum. My red will bend the least, right? So now if I mark arrows inside so that I know where is what coming, always draw arrows. Now we need to mark what is A, B and C. So A is where the dispersion occurs. So A is where dispersion is occurring. B is where internal reflection occurs because it's reflecting inside. And C is where the refraction is happening. If you see our video on human eye and colorful world, this diagram is drawn very clearly and explained in animation so that you know how the rainbow actually forms, and you can exactly replicate that diagram and get your full marks. And listing 2 necessary conditions for observing a rainbow, there should be a presence of sun on the opposite direction of rain that happens, right? That is one of the conditions of rainbow. Now this is how usually this chapter is tested: a theory with one basic numerical or diagram, and you can prepare accordingly. As always, prepare for the defects of vision with the diagrams of it will really help you. Now moving on to electricity. Hope you have not lost any marks in human eye. Let's move to electricity so that we can get our final score out of 20 soon enough. Now starting with the first question of electricity, which is calculating the equivalent resistance of the network. So these are standard 2-mark questions that can come, where the series parallel is tested by asking you to calculate just the equivalent resistance of the. And now first we should start by determining what is in series, what is in parallel. So if you start, always use current to determine series parallel, because now it looks like R1, R3 and R4 are in series, but it is different. Start with current. So current goes like this. It gets divided here. So that shows that R2 and R3 are in parallel with each other. Now this current again merges back to R4. So it will be R1 in series with R2, R3 in series again with R4. So first we'll make this R2, R3 parallel as one resistor, so that you have something like this, where you have R1 and you have the parallel resistor here and you have R4, and then we'll add all of the 4 to get the equivalent resistor. So R equivalent of parallel, which is R2, R3 parallel, would be 1 by R parallel is equal to 1 by R2 plus 1 by R3, which is equal to 1 by 10 plus 1 by 10, which is equal to 2 by 10, which is equal to 1 by 5. So Rp is equal to 5 ohms. So now that you have Rp is 5 ohms, the total resistance will be equal to R1 plus Rp plus R4, which is equal to 5 plus 5 plus 5. So 5 3s are 15 ohm is your final resistance. So this is how you find the total equivalent resistance. Use current. This is a simple circuit. You will go wrong if the circuit is even a bit twisted. So if it comes for 3 marks and it's twisted, it will be scary. So just use current. It's safest method. Now moving on to the next question, which is like they'll ask you something beyond equivalent resistance, which is total resistance of 3 resistors is asked here in this circuit, along with the ammeter and voltmeter reading. So this is like application of series parallel. Here there is not much series parallel, it's straightforward, but sometimes it comes. We'll see that in the next question. And application of Ohm's law. Okay, so this is like a famous chocolate candy question. Like you could just play with VIR and you get your answer. So the total equivalent resistors here, let me label them as, this is R1, this is R2, and this is R3. I'm labeling it as such. So then the total equivalent resistance will be R1 plus R2 plus R3. So that is 2 plus 4 plus 6. So that is equal to 12 ohms. Okay. So now for the ammeter reading, now because they are in series, so here the essence of what you want to find the ammeter reading is, here 6 volt is the total total voltage of the circuit. The current will go like this. So this ammeter reading is basically the total current of the circuit. Now once you have determined the equivalent resistance, you have made the circuit something like this. You've made it into one resistor of 12 ohm. So you just have to find the I here. So the V is given as 6 volts. So the I here again by Ohm's law is V by R, where V is equal to 6, and you have to find the current. The in series, what is that we learn? We learn that all the resistors will have same current flowing through. So you take the equivalent resistance, which is 12. So 6 by 12, which is equal to 1 by 2, which is 0.5 ampere is the current that will flow through. Now comes the tricky part, where we need to find the voltage of one particular resistance. As you know, this will be V1, V2, V3. So here I is common. All the resistors have the same current. So this I is common. So to find V2, I can write I into R2. Right? Again, Ohm's law. So the current is 0.5 into R, which is 4. So this will be equal to 0.5 into 4, which is 2 volt. So 2 volt is the voltage of this resistor alone. So this is how you find. This is a usual 3-mark question, but this is a fairly simple question because I'm trying to get you prepared for the next Ghamasan question which is going to come, which is like the ultimate application of Ohm's law. So this is just to heat your ignition up for Ohm's law, and this is the basic essence of how you calculate Ohm's law. So if it is parallel, the voltage will be same and you can find current for each individual resistor. So based on which is series, which is parallel, you will apply Ohm's law and find out respectively. Now coming to this famous question that was asked 2 times in 2 consecutive years, given its amazing applications, where if you look at the circuit, it's a 12 volt. There is one resistor. They have not told you the resistor value. They've just said that it is R1. And they said that the current coming from here is 2 ampere. You say know that here the current is 1.5. Here R2 you don't know. Here you know the value of voltage, again you know current and resistance. So they have played everything with Ohm's law and you need to find values accordingly. So what you need to find, the first one is you need to find the potential difference across R2. You need to find V2 here. This is the first thing to find. Second, you need to find R2 and then you need to find R1. So this is like, for me with BTech ECE, this is like an amazing question for 10th class. It's testing your actual ability and strength of understanding Ohm's law. So if you do not get an, like how we predicted that Ohm's law could be asked this year a lot because it wasn't asked much, you might get this question in this format this year. Like if you do not get the Ohm's law experiment and graph, this is the next best way to ask you Ohm's law. So let's get started. The first one here being the potential difference across R2. Now I will try to find what I know here. I know that it is 2 ampere current, 1.5 went here. If this is parallel, right? So this is I1, I2. I'm going to label it like that. So if I1 is 1.5 ampere and total I is 2 ampere, it is straightforward that I2 is 0.5 ampere because ultimately 2 ampere only is going out, right? So the current will always be the same. So you have to write I2 is equal to 0.2 ampere. Now if I find out the voltage V1, right, I can get the voltage V2 because whatever is V1, V2 will have same voltage because R2 and 4 are parallel. So I can write V1 is equal to V2 as 4 ohms and R2 are parallel, correct? So if 4 ohms and R2 are parallel, I will write V1 as equal to I1 into R, whatever that R is, R4 amperes. So I'll write R4 because there is no mentioning here. So I'll write 1.5 into 4 ohms. So this 1.5 into 4 ohms is 6 volt. So my V2 will also be equal to 6 volt because they are parallel. Whatever voltage is here, same voltage will be here. Now if I want to find the value of R2, okay, so the same diagram is here, you can watch here. So if R2 is to be found, I know that it is V2 by I2. I know V2 is 6, I know I2 is 0.5. So divided by 0.5, it is 12 ohms. Now coming to, so this is the first part of the question. This is the second part of the question. Now coming to the third part where you need to find the value of resistor R1. So you need to find R1. I know that I current is equal to 2 ampere. Okay, now I can't use any series parallel anything here. I just have to figure out the total voltage of the system here. Now if you see, this is how the system is. There's a resistor here. There are 2 resistors here. And there is one more resistor here. So this resistor is 2 ohms, this resistor is 4, this one we just found out that it is 12. We need to find this one. So what we will do is we will make all of these 3 resistors here, which we know the value of, equal to one resistor. So if I have to find the equivalent circuit, 1 by 4 plus 1 by 12, so that will be equal to 12, 3 plus 1, so that is 4 by 12, which is 1 by 3. And so this total resistance of the parallel becomes 3 ohms. 3 plus 2 ohms. So it's totally 5 ohms. So this whole bunch becomes 5 ohm resistor. Right? So now I have reduced this circuit to this. So it's a 12 volt battery. Okay, there is one resistor here and there is one resistor here. Okay, I've made it a 5 ohm resistor. This one is R1. So the current flowing here is 2 ampere. Now we need to find R1. Now tell me if the current is in series or parallel. It is in series because it's straight. The current is just going across. So I will write R1 plus 5 into 2. So I'm basically saying that V is equal to IR. I'm saying R equivalent will come here is equal to 12 volt. So I'm just saying R1 plus 5 is equal to 12 by 2, which is 6. So R is equal to 6 minus 5, which is equal to 1 ohm. So that is how you find R1 value, which is equal to 1 ohm. In this question, you have applied Ohm's law once, twice, thrice, and also you have done series and parallel. So it's the ultimate 3 marker question where it is not as straightforward. It is not as straightforward. So practicing such questions is really important for you. You can, this is what differentiates toppers, like, not leaving this question but solving it, because it was very easy. You just had to apply your logic, that if it is parallel, same voltage will be there, if it is series, same current will be there. Those logics are what is, that is taught here. Now coming to the next question, which is on resistivity. Okay, so a resistance of metal wire of 2 meters length. So length is 2 meters and area of cross section is 1.55 into 10 to the power minus 6 meters. Resistivity rho is 2.8 into 10 to the power 8 ohm meter. We need to calculate the resistance. So resistance is given by rho L by A. So I will just substitute everything and I will find the resistance. So it's 3.612 into 10 to the power of minus 2 ohms. So this is what is the resistance. It's a straightforward question. Sometimes they will say we will increase the length, what will be the resistance, decrease the area of cross section, what will be the resistance. So you can apply the formula and activate accordingly. The next theory part would be why alloys are preferred over pure metals to make the heating elements of electric devices. Two reasons you can write. One is because of low melting point, they melt late, so all that heat will not cause it to melt. Second is high resistivity, so more resistivity you get more heat. So that is what is the essence. So you can also write an example for this, which is nichrome, which is used, which is nickel and chromium alloy, which is mostly used in all these heating effects that we have, like the iron heater and all, because of these two reasons: low melting point and high resistivity. So prepare this accordingly. I just added this question to give you a flavor of one question on resistivity topic, but this is how maximum it will be asked. Very straightforward. Next question. Now this is a standard question that is asked on power consumption, heat, and heating effect, and all of these topics put together. So let us just start by writing what we know. We know that the heating power of heater, so I will write HH as 4 kilowatt and H of iron as 3 kilowatt. Both are operating at a voltage of 220. So time the heater is used is 2 hours and time that the iron is used is 1 hour. Now first let us do the current drawn by each of them. So the current drawn by heater will be power by voltage. VI is power, so I will be just be power by voltage. So both are operating at same, so the powers will be different. So the power of heater will be 4 kilowatts. I'll write 4000 watt by voltage, which is 220. So this will be equal to almost close to 18.2 ampere, and current drawn by the iron will be power of the iron by voltage total, which is 3000 by 220, which is equal to almost 13.6 amperes. So these are the respective currents drawn. Now let us see what is the total energy consumed. So total energy consumed is, energy is nothing but power into time. So we know that, so power into time. So we know that heater is used for 4 kilowatt into 2 hours. So that is 8 kilowatt hour, and this is for heater. So now next coming to iron, that is used as 3 and for 1 hour, so that is 3 kilowatt hour. So total energy consumed, right, total, which is equal to 11 kilowatt hour. Now if 1 kilowatt hour is 4.5, the cost will be 11 into 4.5 rupees, which is equal to 49.50 rupees. This will be your final electric bill. So this is how you find the current and the energy in the energy consumed and the final cost of it in the circuit. Coming to the next question, this is a little case study question, but trying to relate you on how things differ when there is series and parallel connection. Sometimes they don't use the word resistor but use the word of bulbs, which makes it complicated, and you will get your answer in joules because there is energy also in this question. So you will end up not being able to understand the question. So Read the question, write what is given, you will be able to answer this properly. So Kaveri conducted an experiment to study the energy deficiency of different bulbs. She connected a bulb having resistance of 100 ohms. So first she connected a bulb to a voltage supply of 240 volt in a laboratory. How much energy will be consumed by the bulb if it is kept on for 4 hours each day of a week? So total hours this was kept is 4 into 7 days in a week, which is 28 hours. So that if I write it in seconds, it will almost be equal to 1,800,000 seconds. Okay. Now if I have to find the power that it is energy consumed, which is the power that it is consuming in kilojoules. So the power will be given by V square by R, which is 240 square by R, which is 100 ohms. I will get this to be equal to 57600 by thousands by 100. So this will get cancelled and it will be 576 watt. This is the power consumed by one bulb. Now the energy that it will consume will be power into time. So it is 576 into the time that we have, which is 1,80,800 seconds. So I will get 58060 joules. So if I convert it into kilojoules, that is divided by 1000, it is 58,060.8 kilojoules. Now in 1 week, if this much energy is consumed. Now the second part of question, what she did, Kaveri connects another bulb similar to bulb B in series with the bulb and connect the combination to 240 volt. Will there be any change in brightness of the bulb? Now explain mathematically. So now what is happening? She added another bulb with same resistance. So the total resistance of the system, because they are in series, becomes 100 plus 100 ohms, which is 200 ohms, right? That is the total current. Now if they are in series, what will be constant? Current will be constant. So the voltage is 240 divided by the resistance 200. So V by R, which is equal to 240 by 200, which is equal to 1.2 amperes. Now I will use this current to find the total power. Why can't I use voltage like last time? Because there are two resistors, we don't know what will have what volt. Because it is in series, we will use current formula. So it will be I square R. So it is 1.2 square into total resistance 200. So the total power now will be 144 watt. So now what happens? Each bulb before had a power of, I had the power of almost 576 watt. Now I have come down to 144 watt. So from 576 watt, I have come down to 144 watt, which means that the bulbs will glow more dimmer because the power has lessened, right? Brightness will get reduced when you connected two bulbs in series. Now let us see what happens if it's connected in parallel, just to get a trick, because this was also asked in one of the year. So now here there are two bulbs which are rated. So one bulb is 1000 watt and one more bulb is 60 watt, and they are connected in parallel to the electric main of 220 volt. Find the current drawn. So I is equal to P by V. So I will first find I1, which is equal to 60 by 220. Both will get same voltage, they are in parallel, right? So this will be almost be equal to 2.7 ampere, 0.27 ampere. Now I2 will be equal to, so this is I2, this is I1, let's say. So this will be 100 by 220, which is equal to 0.45 ampere. Now I will say total current is equal to I1 plus I2, which is equal to 0.27 plus 0.45, which is equal to 0.72 ampere. So this is the final current drawn from main is 0.72 ampere. So this is how you solve questions from this chapter electricity. Hope you have scored 7 on 7. And if you have missed out any topic, you're not able to understand anything, you can watch the videos of this chapter, or you can try pausing the video, solve the question, and again recheck the video so that you know where you're going wrong. practice more on Ohm's law, series parallel, the twist and turn of Ohm's law, and also bulbs. These are one of the most tricky questions where they are using bulbs in case of resistors, ask you to find power in respective cases. The ultimate rule of electricity, I'm telling this by studying electricity for more than 5-6 years of my life. Series, current is constant, voltage is divided. Parallel, voltage is constant, current is divided. This is the entire essence of my 4 years of BTech, or it is the ultimate truth, and that is what will let you solve your answers easily. Now coming to magnetic effects of electric current. Here there are some tricky questions which we'll be seeing on terms of, like, we'll use just 3 questions in terms of left hand Fleming rule, right hand rule, how you apply the rule and determine the direction of motion. So either they will ask you to write the rule or apply it. So that is why we are practicing this, so that you don't miss out on this topic. So as per the Fleming's left hand rule, your index finger shows the direction of magnetic field. So use your screen, place your left hand. First thing is, the problem people face is they don't use left hand, start using right hand and get the wrong rule. This is more easy because your left hand is free in exam for most people. Some people in the right hand rule, they'll use left hand because they're holding their pencil in their right hand, so it becomes difficult. So always use the hand that you're supposed to. So using the left hand, if my index finger is showing the direction of magnetic field, okay, and the direction of proton, which is the direction of current, because they're asking you to find the direction of force, right? So proton direction is given by the middle finger. If it is like that, I can clearly see that. If you see the diagram, you can see that my thumb will be sticking out of the paper, so the force will be outward the paper. That is how you determine. You just apply the rule as such. You have to figure out index finger magnetic field, proton will have current, positive current, so current is going downward. So my thumb is coming out, thumb gives the direction of force, so it is coming out of the paper. This is how you find. These are general 1 mark 2 mark question. If it comes for 3 marks, they'll ask you to state the law. Now coming to next question. See, the Fleming's left hand rule states that the force is maximum when the electric field and magnetic field are perpendicular to each other. You will learn more about this in your 12th class, why it is maximum when it is perpendicular, because there's some trigonometry involved over there. So because it is perpendicular, it will be maximum. So that is something given in your textbook. So you know that it is 0 when they are parallel with each other. So this case, it is 0. The force is 0. When they are both in line, there will not be any force. And it will be maximum when they are perpendicular. So in case I, they are perpendicular, so there is maximum. Case 3, it is parallel, so it is minimum, which is 0, right? And in case 2, what happens is there will be some amount, but it won't be highest. There is some, it will be greater than 0. It won't be 0, it will be greater than 0, but it will not be maximum because there's some angle involved here between the electric field and magnetic field. This is something you need to prepare and learn, and this is one of the good questions that had come last year. Moving on to the next question on right hand rule. Imagine a current carrying circular loop of wire in a plane of your answer sheet. So imagine the current carrying circular loop, okay, in the plane of your answer sheet, okay, and the magnetic field inside the loop is going into the paper. So it's going into the paper like this, okay. What must be the direction of the current? Okay, so state the rule used here. So if this is going into the paper, use right hand. Always right hand. When there is no force involved, it's right hand. So if my, just take your right hand, place it such that it is going into the loop, into the paper. If it is going into the paper, my thumb is showing in this direction. So my thumb is like this for it to go into the paper. So this is how you use the law to apply this logic here. Again, practice. Use the right hand, not the left hand in this case. Use the right hand. You will be able to determine the direction accurately. Here you will have to just draw the direction, draw the diagram, and say that this is the current, this is the magnetic field. And the rule used here is right hand thumb rule, right? And you will state the rule. So if the Current carrying is represented by the thumb. The curled fingers give the direction of magnetic field. So I did one thing of curling my fingers into the paper and I saw where the current or where my thumb is pointing. You can always practice more and more questions, more and more numericals. Now that you have an idea on which questions you are finding it difficult, you can definitely practice those type of questions, more formats, and always practice makes you better. If you solved at least 15 out of these 20 correctly, you're already ahead of most students. But don't stop there. Prepare theory by watching individual videos of each of these chapters, or you can watch the full length physics rapid revision where you can grab all the theory marks that you need. Click video and complete your physics. Click on the video and complete your physics preparation. And until then, see you in the next one. All the best for your exams.